All right, let's get to it today. Bit late, so yeah, let's let's dig in. Last time, as a recap, I was trying to get the stupid software scrolling working so that when we hit the bottom of the screen and we scroll by a line, we'll use the NES's software scrolling to automatically scroll the tile map by one. But we also need to clear, like that much seems to be working more or less okay, but we also need to clear, I think, the current line that we're about to print, and that doesn't seem to be happening. I think I'm probably clearing the wrong line, but we're so close. Like, this is the last thing I need to implement to have text output services implemented. And then we can work on this keyboard. Also, as a side note, I ended up getting a table at VCF Midwest. Again, I was there last year with a underwhelming presentation, and I plan on being there again this year with an underwhelming presentation. That is the weekend of September 10th and 11th in Chicago. You'll have to look it up. I should probably link the thing, but I don't have it. But anyhow, I'm going to try and bring whatever I have of the NES project just for shits and giggles, because why not? Because it's fun to be a part of VCF Midwest. So if you're, in the area, I will be there with something. And I don't have a lot of time to get this done, so we might just have an NES that you can type text on. If it gets really close, actually, you know what a thought is we could possibly, if I can get the keyboard working, we can, if it doesn't look like it's realistic to get BASIC going, maybe slap a UART on the thing and connect it to some kind of other hardware so that we can, kind of use the NES as a terminal. Is a thought, but it's a pretty ridiculous one. So anyway, let us dig back in and find the one that is my screen. It's this one. I found it the first time, but I didn't trust myself. But yeah, so this is more or less what we had last time. I will restart this. Is the debugger paused? Yes, it is. So we print some text, and then we hit the bottom, and it's because I had a breakpoint here. So let me clear that breakpoint. And if we continue, it scrolls. Looks like pretty reasonably, but oh well, that's interesting. Okay. Anyway, so you can see this to the left line never gets cleared, and that should be like, well, it should never show back up on the bottom side of the screen. I was going to say it should be the first thing to be cleared, but it would really probably be like the last thing to be cleared. But regardless, that should have been cleared. But actually, if I reset this, I noticed something that I didn't really notice last time. As this refreshes, see how it blinks there? It looks like this is the line that's getting cleared, which is not right. It should be the bottommost line that would be getting cleared. So that is probably our issue right there, is that our actual position where we are like scrolling and setting the next character and all of that good stuff would appear to be off. And that makes sense to me. One thing that I was going to do really quick, just to make things a little bit more obvious for myself, is apparently I do not have the PPU viewer up. Let us open the PPU viewer. Not the name table, the PPU. Let's grab some random character. I'm just going to use one of these white block characters. And that way, instead of filling it with a black space character, I can very clearly see which line is getting cleared when it gets cleared. Because it should scroll in from the bottom and be a solid white line. Let's choose this one. It's 7C, which works great because we were using 7D, so just gotta switch this to a C, rebuild, and that should make things slightly clearer. You can do it. There we go. Open. Nope, that's close. I have no control over my mouse. Basic.NES. Okay. So it shouldn't do anything until it gets to the bottom of the screen. And that delay is so weird. I think we're like printing off the bottom of the screen or something before the scroll ever happens, because we should be scrolling a lot more than that. So, firstly, you can definitely see these are the lines that got cleared. That is super not right. We should have gotten these lines cleared as well. So there's a lot wrong going on here. Wereworm and Trey Dempsey have arrived. Good to see you guys as always. So where should I put... This is probably some like math that's really straightforward that I'm screwing up here. My guess is if I put a breakpoint at when it first starts scrolling, I'm guessing I'll probably see a print address of something that seems right to me but is actually incorrect. That's going to be my guess. Yeah, because actually if I look at, let's see, these 7 Cs, there really shouldn't be 7 Cs anywhere else in the PPU memory for this map. So I can actually look at what addresses those are at, because I can't quite tell just from the screen because it's been scrolled. So let me look at the, it's under debug, hex editor, and look at PPU memory and look at 2000, the 2000-ish area, and I'm looking for where those 7 Cs are, which I see a bunch right here. Is that all of them? It can't be all of them. There should be like 32 times 1, 2, 3, 4, 5, 6, 7. There should be 32 times 7 Cs. So that's kind of odd. Oh, I'm looking way too far. Looking way too far into memory. That was the start of the second name table, I think. There. There's my 7 Cs. So these characters right here are going to be our here characters, and then these 7 Cs are the cleared lines. And that starts at address 2300. And the last one is at address 23B0. And, I mean, that makes sense. That is the bottom of the map. So those lines are actually kind of in the right place. So it looks almost like my printing and my scrolling are like off from each other by 1, 2, 3, 4, 5, 6. Maybe 7 because we have a secret line up here. Maybe 8 because we might have a secret line down here too. I am not quite sure about that. And yeah, so this is the area that has scrolled, but it's not in sync with the actual scroll offset. So that is interesting. So now I have to think of where to start looking with this. Because basically this part is right. Based on the addresses, these 7 Cs are in the right location. But the scroll is not. So yeah, let's set a breakpoint and check out when it first... Let me run this again just so I can get a really good understanding of the behavior as I watch it. Prints, gets to the end, and it does scroll. But see that, you don't get the cleared out lines for a while. Probably that difference of 8. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. It's going too fast for me to count. I was trying to see if I could get a good idea count-wise of the difference. I mean, 16, 17, which is kind of where I was at, seems kind of right if it's the sum of these and these. So interesting. And the real tough thing is, I can't really tell if it is, if it scrolled once and then kept printing without scrolling, Let's see if I can see that, obviously, on the name table viewer. So it starts out, we're all the way at the top. Yeah, interesting. Did you see that? So it might be hard to see because this is so small on your screen, but there's definitely just like, it scrolled once, then there was a big old pause, and then it just kind of jumped, didn't it? Let me see that again. Yeah, so it scrolled once. Yeah, interesting. Then there was like this big old pause. So I feel like it's got to be, it's probably a condition, like it's got to be like one of my wrap checks, because if we run it again, I bet it's something like we get to the end and it scrolls the one time, the first time that we detect the scroll, but then it doesn't get back to the part where it checks if it needs to scroll on this line until like one of the special cases gets hit, like the screen address wrapping or something like that. I bet what it would be. So let's double check that code. So let's just start from the start. So when we print a character, blah blah blah, we do the lookup, and if it was 0, which our new line character would be, we go to check control, then at check control, and yeah, because it might be that this code doesn't get executed. Anyway, we get to check control, we check to see if it is a carriage return. It is not, it wasn't, so we jump to check line feed. If it was a line feed, then if we jumped here, we check if it was a line feed. If it was not a line feed, we exit. If it was a line feed, which it was in this scenario, then we grab the low screen address, we add a line width to it, we store it. Then we clear the X bits out of the address. So now we only have the low Y values. And finally, we jump to check scroll needed. We jump to check scroll needed only if this was cleared. And only if the whole thing was 0, which would be, yeah, I'm seeing an issue there right now. Right, because, yeah, this is all very, very funky. I'm surprised this kind of works at all. So what this is doing is it's clearing out the X amount and checking to see if the Y portion had wrapped back to 0 when we added this new line. And if it wrapped back to 0, no. So yeah, if it wrapped back to 0, then if not 0. So if it didn't wrap back to 0, sorry, other way around. If it didn't wrap back to 0, then we can skip this code, which is incrementing the high Y portion of the address. But that didn't happen. Or even if it did, whatever. So this much makes sense. And either way, we should have, because we didn't mess with X here, or we didn't mess with A here, we only messed with X. A should still contain the low portion of the screen address ANDed with E0. So just the low Y bits. So either way, now we are in check scroll needed, and we are taking A, again, the low Y portion of the screen address, and putting it into X, grabbing the high screen address, putting it in A, and checking to see if it was 23. So this is the checking to see if we're at the end of the screen. But let's see. This is the part where it's probably going to start happening. So this is checking to see if it's at 23C0. So we check to see if the high part is 23. If it is not 23, then see, this is probably it right here. Because we shouldn't branch to print character end, even if the address isn't 23C0 and we don't need to wrap the high part of the Y address, we still need to check whether we need to scroll. So we need a new label. Maybe, I guess it could be right here. I think that would be fine. Check scroll flag. Yes. Yep, I almost guarantee that's what it is that this code causes this whole chunk, even if the we are scrolling now flag got set previously. If the high part of the video address that we're writing to isn't 23, we're skipping everything, including the check to see if that flag was already set. Then you do need to scroll. So even if it was not 23, we still need to not just bail out of printing entirely. We need to jump to check scroll flag. And then finally, if it is scrolling, well, if it's not scrolling, then we bail. But if it is scrolling, then we jump to screen scroll. That seems much more reasonable to me. And fingers crossed, that might be the entire problem. I kind of, speaking that confidently makes me wary of it working the first try, but that would definitely be a problem. Let's load it. Open basic.nes. Fingers crossed. Fingers crossed. I think we're done. No, we're not quite done. We're not quite done. So now I need to make this code common to both. Well, firstly, I need to clear out the white, because clearly that is just for debugging. But I also need to plug this code in and do all of the scrolling if we go to a new line because we wrapped at the end of the line. Because right now we have code that checks if we were printing a character, hit the end of the line, then we move down one. And right now, if we print to the end of the line, it won't scroll if we hit the end of the screen, which is screwy and makes things all out of order. But before we start screwing with that, which should be fairly straightforward, it'll just be taking all of this code and kind of, I don't know if I want to break it out into a subroutine or just code to be jumped to. I guess it can't just be code to be jumped to, because we'd have to know the return address of whatever our caller is and head back to the appropriate location. So probably need to make it into a subroutine, but that should be it, is rejigger into a subroutine, call that subroutine from the new line handler, and also call that subroutine from the we wrapped handler. But like I said, just for fun, let us replace wherever that 7C was and replace it with 7D again so that it actually looks the way we would expect it to look. File, open, and then I'm going to review chat really quick because I see that there was an influx of folks. Here. There you go. It's not that impressive because it just keeps printing here and eventually it stops, but we can't tell. But the fact that as this scrolls, because of the way that we have set up the mirroring, it's the same screen on top of itself twice. So the fact that we scrolled down and didn't see the first line of text that was printed means things are working. So let us double check chat. Wareworm says, so what about printing an incremental character as was suggested? Didn't have to. Ha! It's a perfectly fine suggestion. Trade MC says, I was thinking it might be easier to track the cursor position and the viewport position. You can probably combine them, but it'll be harder to reason about. You could. Again, I'm going super pedal to the metal and just using my address into VRAM as my X and Y location because they are encoded actually surprisingly cleanly in there. You can probably combine them, but it'll be harder to read. Should it decrement the position if it scrolls up one line? I mean, if it is on Y max and scrolls up one line, it is at Y max again the next time. No, because the way things are going right now, basically the window is scrolling one way, and the incrementing of the address through video memory is going the other way. So, yeah. I mean, they're both increasing, but one increasing causes basically your view to go this way, and the other increasing causes the characters to go this way. So it kind of keeps up with it. Lawless, hi. Hi. Wereworm says, yeah, I finally got to the part. Okay, if it works, it's fine. Confused. I'm not going to think too hard about it. That's my trademark. It does indeed work. Anyway, okay, let's subroutine it. So, for starters, let's just, I guess, let's see. Dang. So one of the things that we definitely have to do, well, we could always assume that the caller, because right now one of the big things that we're assuming is that when we get to check scroll needed, the bottom part of that the accumulator contains the video address we're writing to with the low bits cleared, and maybe I can just force that to be an assumption going into it. That's a thought. What else does this depend on? Because I don't think it really depends on much. It's just, if you detected that the screen needs to scroll, you jump into this code, and then it loads the screen address and checks the high screen address. And oh, that's actually stuff that I kind of need to rip out. No, actually, it's not. I do need that. So we gotta check if we've hit the bottom yet. It's the screen scrolling code that checks to see if we've hit the bottom yet, not the caller. So we keep that. And yeah, I think most everything else, because at this point we've destroyed the value in A, we weren't using Y for anything, and we have jammed A into X, so whatever was in X is garbo at this point. So there's nothing else that we could really be assuming state-wise in here as far as the registers. So I think we're kind of okay to grab all this. Oh, yes, actually. Wrap Y address. Is that wrapping scroll address, or is that part of our other code? So we check to see if we're at the bottom of the screen, which is 23C0. And if we, let's see, if we were 23C0, they were equal, then we need to wrap the Y address? Oh, because we don't need to check the scroll flag, because we'll be setting the scroll flag. And then wrap Y address, I'm just checking to see if that's the part that actually, that's really part of the new line code. Yes. Yeah, 'cause what it's doing is loading the low portion of the screen address. Grabbing, we're clearing out the Y, but trying to remember what I did, especially in assembly, and why. Would be better if it was commented. I should have commented this. But this is only allowing the X portion through for some reason. And then we're storing it. Oh, because we're clearing the address, because we're wrapping back to the we're basically wrapping from the last line of video memory for this map back to the first line. So actually, yeah, that's fine. Yeah, because for the collar, I guess that would be this would be invisible to the caller. The caller is just going to be like, I moved to the next line, and the scroll code will take care of, you know, wrapping if we ended up on the next line, but the next line is actually, you know, outside of the name table. Then the scroll code should take care of that. So this is also still part of the scroll code. Very good. And then finally do screen scroll should just be doing screen scroll. And the line clearing and setting the scroll value and storing it, and that's pretty much it. So I think basically we can, this looks pretty well self-contained. So I'm going to do return to, what is the S? Return to sender? Don't know. That is the correct one, right, too? RTS. All right. And we can clear these. And now I shall take all of this. And I still may need to clear some labels out of this, because they may be jumping to places that are hard-coded, but I'm not sure. I'll have to double check. So everything. Yeah. I think this is pretty much it. Oh, no, I needed that wrap scroll stuff too, didn't I? Yes, I did. So undo that. Yeah, I guess I can have a return there, because this would just return to the caller if we didn't need to wrap the scroll value. And then finally we will do it again, because we can't just assume that fall through will work there, because we're going to be in a totally different area of code. And I'm way past where I need to copy. All right, so take that, steal it, throw it elsewhere. You go here now. Subroutine for software line scrolling. All right, that was fine formatting wise. And I will need to fix that up some, but let's do that. Go back here to print character and do. Oh, right here, right? Yeah, so basically, do line feed scroll. I'll put a label here called do line feed scroll. Let's go ahead and make that an underscore A. And here we will call into the line feed code. I don't think we need to preserve any registers. We're not saving anything special. So I think all we need to do is jump subroutine, whatever that was called. And actually, let's call it check and scroll, and I'll go rename it. Check and scroll. Check and scroll. Cool. And I mean, I guess I could really just make that part of print character end, right? Like, there's no reason not to. Yeah, I don't see any reason not to. PRNT. Right. My my unevenness with labeling things is going to get me killed. I guess I'm still thinking about this E0. Yeah, I actually won't do that. Oops. I will not just make that part of print screen, print char end, because like it's we don't need to call that at all from, for example, here or any place else that we early exit from print character, and none of those are doing this pre-setup step of sending a zhuzhed up low video address. So yeah, we'll keep it like that. All right, let's see if that just works. I'm just gonna see if that just works. I'm sure I need to probably fix up some stuff now that I've moved that code down, but maybe we'll get lucky. File, open. Looking pretty good. It might be fine. I might have gotten real lucky there that was all I needed to do. What shall I do? Let's do the 7C thing again, just to be sure. File, open, basic.mess. And now we should get lines cleared with the white. Yep. Looking good. So that appears to have been as easy as that. Maybe. So now all I have to do is call that same shite if we did a wrap. And double check to see if I need to save any of the registers when we do a line wrap. Print character, step character. So we increment. So step character is the thing that happens right after we printed a valid character and is moving the cursor, which is just the next address to write a character to. So we increment the character, the low address. We store it in the low address variable. Then we check to see if we are at the end of the screen. This is the part that checks to see if we were about to wrap, apparently. Let's see, we take X and put it into A. X was our low part of the address. We AND it with 1F, which 1F will clear out everything except for the X portion of the address. And then we check to see if they were all full. Oh, right, we don't check to see if it's just wrapped because we want to leave that margin on the one side so that it looks good on my TV. Right. If it did not hit the end of the screen, that's fine. If it did, yes, then we need to increase X one more because we want to move two characters because we gotta handle the margin at the right and we gotta handle the margin at the left. And once we have done that, we branch back to step character to run through it again because potentially we weren't at the end of the screen, something like that. Yeah, this is overkill now, isn't it? Because yeah, it's pretty much overkill. Let's see. We could just increase X twice. There was a reason that I was doing this. And then somebody told me, don't you not have to do that? And I was like, yeah, I think you're right, but I still don't trust doing that for some reason. Anyway, I guess what we can do. So the screen scrolling doesn't actually increase our address. It just checks to see if we need to scroll the screen and if the Y wrapped, wrap it again. So I think really, let's see, how do we exit out of this? we exit out of this because the second time through it won't be 1F. I'm just trying to check if there's any logical reason that we actually need to be doing this, because if not, I will simplify it, and that'll simplify calling this subroutine now too. So we increase the X address, we store it. If it was not 0, interesting. I think this might just be weird like this because of the wrapping we were doing before. Because why would I check to see? Why would past me have checked to see if the screen address that we just incremented was 0? Because we should really actually never hit 0, because we check to see if it's 1F and skip right over the place where where the X wraps. Interesting. So I think this might be redundant. And Y contained... Oh. God, I am so slow at reading assembly. It's doing the screen address wrapping. Right, because this doesn't really know or care about the difference between increasing an X and increasing the Y. This is just linearly increasing the memory, and this, or the pointer basically, and this is checking to see if we wrapped. So we increased the low byte. If it was 0, then that means we wrapped, and we have to increment the Y, or the high portion of the address. That's what this is doing, and then that's why we're looping through again, because that second time potentially, and this may not mathematically be necessary. I don't know. I don't want to think about it too hard, but it would work either way. When we increment it again, we also want to see if we needed to increase the Y address, which, yeah, we would want to check, because basically, even though we are definitely incrementing to the next line, and incrementing the high byte only happens when you increment a line, it doesn't necessarily happen when you increment on a line, because some of the Y value is in the low byte. That's why. Anyway, now with that sussed out, so we potentially loop through it twice, and then how do we get out of here? We get out of here because on the second loop, it will definitely not be 1F. And if it is not 1F, then we jump to print character end, but actually we don't want to jump to print character end. We want to jump to what did I name the other one? Do line feed scroll. Let's call this do wrap scroll. And I think this should be basically the same. So do wrap scroll will firstly and annoyingly, ooh, actually no. This is useful, because X, we know X contains our current low byte, which we need, but we need it ANDed with E0. We can just do TXA again. We don't have to like reload it from memory. So TXA again to get an unmolested copy into the accumulator, then AND it with E0 as the subroutine expects. And finally, JSR, whatever we called that routine, check and scroll, height. And then when it is done doing check and scroll, then we're done, right? Yes, because this is where it would have exited and finally gone off to the end of the thing. So here is where we can do our redundant clear carry, branch carry clear to print char end. And as such, if we, firstly, just because We should never hit that code with our current like demo code, but let's run this again anyway, just to make sure that it still runs okay. Which it should. I don't expect anything weird to happen here. Oh, whoa, don't I? What was that? Fascinating. See, this is why you check. Okay, I want to watch that one more time. Clearly we're scrolling way too often. Oh, that's fascinating. All right. Okay. What the hell? What the hell just happened? I didn't touch that code. I mean, it's obviously because that call to the subroutine from the wrap check is getting called when it really shouldn't be, because none of our code is actually wrapping. We don't print any strings long enough to wrap here. So I am lost in my code. 1 second. Wrap. So why is do wrap scroll getting called? It is getting called because, let's see. Let's read all of the print character code really quick. Look up the tile number of this character. Yep, we've been over that several times. If it was not a printable character, we go to check control, which should be fine, because we don't, that'll jump over all of this. Otherwise, it was a printable character, so we increment that address, or we don't increment that address, we just load the next address that's stored in screen address into the address of the PPU, and then we store the character in the video memory, which actually prints it. Then we advance the character, and this is where it's probably going screwy. So our low address was in X, because we just loaded it up here. That's the last thing that went in X. And we store it in the low screen address. If it was 0, and if it was not 0, we didn't wrap, so we don't need to wrap. If it was 0, we increment the high portion and stash it. And then, because it would have to be, well, either way, we get to check end of screen. We take our X value, which we know is the low screen address. We do that check to see if it is at 1F. And if it is at 1F, let's see. We AND it with 1F. We compare it with 1F. The X value was 1F. If it was not equal to 1F, then we don't need to do wrap scroll. We don't need to do wrap scroll, you dingus, because, yeah, that's why. Because basically after the scroll flag gets set, every time we hit here and we're not at the end of the line, it scrolls. Because this is backwards. So actually, this should just be... This should just go to the exit portion of the method, or the function, right? I think. Because only if we... Oh. No. Oh, this is... I have complicated this for myself, because this will not be 1F either if we came through this loop the second time, because of this, or if it just wasn't at the end of the line. So I need to be a little more clever about this, or maybe not clever, just I have to do a little more checking. Let me look at chat really quick, because I feel like I'm getting really close to basically having this done, which is neat, but I want to pad it out just a touch. So let me see if they have any thoughts. Coco says, basically, I'm trying to get WX widgets to work. What are you building? I feel like I've used WX widgets like one time for one thing a bajillion years ago, and I don't remember a single thing about it except that it's incredibly portable. There's a fly down here, and he is ticking me off. Wereworm says, so instead of a conventional scrolling in a fixed viewport, the viewing window is scrolling down with the text. Strange. Yes. I mean, that's kind of the way that software scrolling works. Because you are kind of chasing the last line printed with your viewport. And then your viewport is eventually going to wrap because we have 2 copies of the screen, so it would eventually hit the bottom of the second copy, which is at which point you can just reset it because that's the same as being in the first copy again. And the addresses will wrap at this boundary too for printing text, so you're just kind of chasing the text down the screen, and when you get down here, both where you're printing and where you're scrolled to is set to pop back up here. So you're just kind of chasing it down the screen, and because of the wrapping, as long as you're always clearing this bottom screen and this bottom row as you approach it, it kind of clears out memory as you go. So, you know, you're leading the kind of the dirty memory. Dirt Piper says, hello, I return. 1 appendix later than previous. Jesus Christ, Dirt Piper, did you mention that you had an appendix problem going on? I guess that's good. They wouldn't take an appendix out if it wasn't for a good reason, so good on you. RZZX capital T says, I am liking the content, thank you. No problem. I'm enjoying making it. Wereworm says, looks like the assembly equivalent to a missing else. You introduced jumps, but not the skipping if the criteria is not met. Yeah, pretty much. Pretty much I need to add an extra if check in here to see if we're on the second loop or if we are just coming through the first time and we're not at the end of the line. So I think I should just be able to check if it's 01. Right? Yes? Yes? Anyway, Trade MC says, clap. You found what I was yelling at my TV. I bet that was in reference to something that I have said and now forgot. Dirt Piper chimes in with his story, his harrowing story of the appendix. He says, I had abdominal pain pretty much the entirety of last week. It went away on Friday and returned Saturday with a vengeance, deserving an ER visit. I was torn asunder within 12 hours. Jeez. I mean, that's pretty much the way it goes, right? Like, it's nothing. Hey, we have to get this thing out now. Well, I'm glad that they caught it and you are, sounds like, doing good. Because I don't want to lose a viewer, you know? It's really mostly, it's not about you personally, it's about my numbers. Okay, well, let's do this. So let me think about this really quick, because basically, I just need to do another check. So I compare it with 1F, because if it's 1F, that is the very last character on the screen, which that's not where we printed. That's just where we printed here, and then we are advancing 1 over. And if we are in 1F, which is the character at the very end where I want to put a margin, then we are right now. If we're not there, well, before if we weren't there, we were just exiting. Now, if we weren't there, we were going to do wrap scroll, which is also wrong. And we kind of want to not do both, because what we want to do is, if it is, I guess if it is 1F, then I'll make a new thingy, and I'll say branch if it was 1F, then we'll jump to this label, I don't know, I'll call it step over margin. And if we go to step over margin, that's this bit. But then we can also do another check and compare it against. So if we were doing this through step over margin, what's going to happen is it was 1F. So we go into step over margin, it becomes 2O, which is we've bled into the Y portion of the address. So Trying to think. I guess. So what'll happen is that'll go to, well, it won't necessarily. No, it will go to 2-0 because I anded it. So yeah. So we increment it. Oh, this is actually interesting. This might be a bug. Let me read this more properly, because if we are using, yeah, we are potentially using this as the actual low screen address, which would be incorrect. We've only checked it on low lines. That's why we haven't seen this yet. This would only be correct like the first time we do a new line, because I have cleared out all of the Y bits here. Yeah. So actually, we need to do TXA down here. That's the only way this will work properly. And then, ooh, wait. So at this point, oh no. X contains the unmodified value, so we're actually good. Sorry, that's not a bug. Right, I was confusing myself. The ANDed version is in the accumulator, not in there. This is not a bug. Okay, past me was smarter than I gave myself credit for. So anyway, we were back at, this will, let's see. We will, so right here we said X contained something where the low bits were 1F. We compared it with 1F the first time, we came back around, or no, we jumped to step over margin, increased X again, which is where it would not become 2-0, it would just become the next Y increment, and all of the X portion would be 0, which is the low 5 bits for those who are playing along at home. So yeah, so that's actually pretty easy. If we come through here again, the only way to get to position 1 on the current line, to X position 1, is by hitting this code and jumping across the margin. So that's what we check, is if we ANDed to get the X values and it was 01. And I managed to close the file. Good job. Right, so if it is 01, then we can go to, let's see. Have to think about this. Have to think. If it was 01, then we are exiting. We were here in the first place, so we know that we are doing a character, or a line advance. So I'm just trying to think, because there should be a case here, right? If there should be a case where we just exit entirely without doing wrap scroll, because if it isn't 0-1, oh, right. So what we're gonna do is we'll jump to do wrap scroll if it is 0-1, because that means we did in fact go to a new line. So let's do that right here. Do wrap scroll, and then we'll do a. If none of that was true, if we didn't start doing a new line increment, a margin hop, and we weren't ending a margin hop, then that just means we're on some random character in the middle of the line, and we can just exit. We don't need to check for scrolling at all. So our old friend, clear carry, branch carry clear, to print chart end. That is my logic, and I'm sticking to it. So let me just grip it and rip it and build it. And oh, that's not good enough. Well, we can at least check to see if the previous bug is now not happening. Now it should have worked just the way it was before. Fingers crossed. There we go. Cool. So now we need to actually test the wrapping behavior to make sure that the wrapping also does the same thing. And that should be a very easy test. What we need to do is, instead of, let's get to the actual main loop of the program. Right here, print loop. Yes, instead of... because right now what we're doing is we're printing the here string, and then we are doing a line feed character return, or carriage return. So all I need to do is remove the line feed carriage return and make this string funnier. No, even better. Even better. For those who will get the reference. Okay, and hopefully this should just keep printing it, get to the end of the line, wrap, and finally when we get to the bottom, do some scrolling. So actually, just to be very thorough, I am going to even yet again increase the amount of scrolling. Let's just max this guy out. The X register in this case is the loop counter for how many times to print this string. And hopefully, it'll just work. Well, that ain't right. Pretty interesting, though. The basic wrapping works okay, but it never triggers a scroll. It never once triggers a scroll. What do you say, chat? Dirt Piper says, glad to be alive. Heck yeah. Wereworm says, you might be eaten by a grue. It's not a Zork reference. It's a dumb... I don't know where it aired first, if it was like a BBC 4 thing or something, but it was definitely on Adult Swim. Don't know if it originated on Adult Swim. Excellent stupid show. It was like... it was styled like mid-70s, or like, I guess really... just that kind of like old school educational, you know, like let's have movie day, but like it's a way out of date film kind of thing for school, except it's bizarre. They had such things as detecting ghosts, comedy show, classic. But they would open, I don't know if they opened every episode. I think they opened every episode with like a, you know, like a BBC micro or something printing "Look Around You," which was the name of the show, on the screen like this. Yeah, look at all the things. So, like I said, the wrapping is looking right, but clearly we are hitting, let's see, this is line 0 is hidden up here. 1, 2, 3, 4, 5, 6, 7. And then for some reason we're hitting 8 and just going back to the top. Which is kind of weird because, well, actually that's probably some... I wonder what... I'm trying to think of why 8 would be significant. But it's definitely that something's not wrapping properly. What's the best way to check this? I'm just going to look at the code. Always start at the code. Always follow the logic. And if it doesn't work, use the debugger as a crutch. For that is what a debugger is. Gerald says, why getting clobbered by auto wrap? Possibly. And yes, Trey Dempsey says, shouldn't you scroll only when you reach the bottom of the screen? And the answer is yes. This is a bug. Right, so let's look at what would that address be when we get down there. Because it's got to like happen before this stuff, before we check the low byte. Maybe. Does it? No, because this is the part that actually checks. See if we step over the margin. So, processing. Let's just step through this saying, yeah, it's got to be clobbering the high portion. Because how many bits do we have to store I think we have 3, yeah, we have 3 bits to store the low part of y in the low address. And that is 8. Would you look at that? So that's definitely what it is that we're not, somewhere we're not incrementing the high byte, which is funny because, yeah, it's probably that this is screwed up, because that was part of this whole freaking thing, is right here to, yeah, to check this shit. Are you saying, yeah, Y address not getting updated, I mean? Yeah. So, the question is, why wouldn't it detect a wrap? And probably because I'm doing this wrong. Yeah. So let's just say, what would that be? So that case would be that our low byte would be FF. It would be just full. So we hit here, we step the character. First thing, we increment X, blah, blah, blah. If it was empty, that means we, sorry, if it was not 0, that means that the low byte didn't need to wrap, and we can jump here. Subsequently, we take the clean low byte, put it back in A, check the X, see if the X was 1F, which is the last X character. If it was 1F, we go to step over margin, which skips the checking to see if it was done doing a step over the margin. We know it was 1F because the address was FF in that case. So we increment it again, which will set it to 0. Then we jump back up to step character. We increment it again, so now it is oh, wait. Let me think about this. So what is in X right now is the clean low address. So shoot, I see. Crap. You know what's happening is right here is where we should be checking to see if we need to, because we it would have wrapped the whole thing to 0 right here. It wouldn't have just wrapped the X portion of it. It wraps that whole byte back to 0. So when we jump back up to here and we incremented it again, it's at 1, which is the right address, but it also means that when we do this check, we store the address, then we check to see if it was 0, and it was not 0, it was 1, so we don't increment the screen address. So you know what, let's just do the same thing, and we'll just unroll this thing. Yeah, F it. So that is here, and it will always be this first increment. I should have lost an I somewhere. Oh, let's try that again. Yes, so when we do step over margin, we should increase the X, check to see if the whole byte needs to wrap, which is possible. And this will need to jump to a different place. Here, I'm just going to call it, because this is just here to jump over the high byte increment if we don't need to do it. So I'm just going to call it, because we're having fun here, keep on stepping. subsequently replace this, keep on stepping. And I feel pretty confident about that, except for the fact that I did not put a colon on my label. As I have mentioned many times, always take care of your colon. Your colon is more important than you think. All right. Hopefully now we will at least have a new, more interesting bug. So immediately I think something about my math is wrong because my left side margin is, it would appear one character too large. And perfect. It worked, you know. I see no problem with this. That's fun. Gets to the end. Doesn't detect that it's at the end. Overwrites the attribute memory. Keeps on going. Yeah. Okay. I wonder if that is related to the left-hand margin being off by a bit. Let's run through this again. Because you can always figure it out by running through the code with a test scenario. Because that's how code works. Let us see. Yeah, Trey figured it out a while back. He says, how many lines is it? 8? 2 to the third, 3 bits? Yep. That's what it was. It was 3 bits indeed. So, right. The question is, why is it going 1 too far? Because we do need to increment twice, because we want the next character to end up at 01, not 00. Yeah. This needs to be removed, right? Yes. Yes. All of our shit needs to be fixed up. Because this should not wrap back to step character. Didn't clean that up. This should... I guess it's okay for that to still flow through to do wrap scroll. But... ooh, let's see. Yeah, I didn't think this through well at all. So when it needs to step across the margin, we increment X. There's really no reason to store it at this point, because we know we're not going to store it. We just need to see if it wraps. Yeah. So we increase it. If it was not 0, didn't need to wrap, then we move on to keep on stepping, which is where we will do the actual writing it back to memory. And then if we did need to wrap, there we go. We update the high byte, and we do not loop back to the beginning, which is probably causing a lot of havoc. And then the first time through, we increase X, check it, basically do the same thing, jump to check end of screen if we didn't need to increment the high order byte, check to see if it was at the last character position. If it is at the last character position, then we jump to step over margin and ignore all of this stuff. But also, because we are not coming through this loop a second time, we don't need to do this at all. And let us think about this. So if it was 1F, then I guess we could make our lives make a little more sense by calling this, by doing branch if, hold on. So we were saying if it was, yeah. So if it is not equal, branch not equal, this just reads a little more sensibly now. Then we jump to print character end, because there is no need, we're not stepping over the margin, so there is no need to do any of this stuff, including checking for the scroll. Now, this label is pointless, but I still like it because it kind of documents the code a little bit. So if the bottom character hadn't hit the end, then we're done. Otherwise, we step into here, increase X, check to see if it needs to update, if it wrapped to the high byte as well, again. Subsequently, whether it did or didn't, it gets to here. This is backwards. Increment X again to get it fully across the margin into position 01, and then store that value. Then, again, this is now a redundant label, but regardless, if we have decided that we need to step over the margin, then we do that check, and finally, every single time, we go to do wrap scroll, where we take the clean version of X, the clean version of the low address, which is in X, put it in A, and it with E0, do the check and scroll, and finally, we are done printing the character. So let's see if that improved things at all. Even though, can you really improve on this? This is pretty good. Fine, I will run it. It will be boring and correct. Okay, that left side margin actually looks correct now. Luider Oljundunda. I do wonder if we have an off by one a little bit, but this looks to be doing its thing. Yeah, we've got to have an off by one because you can't see the line printing. And that potentially makes sense just because, again, I said last time, and I continue to say now, I don't really know how or why it would make sense, but there's a hidden line at the top of the screen. Oh, you know what? There might just be a hidden line at the bottom of the screen, too. Duh. I had said that before earlier, and I didn't really think about it. Right. There's probably like an overscan line also below this displayed area, just like there is one above. And it's working. It's printing a line there, but we actually don't. We want to scroll before that, right? Yes, we do. Which should be straightforward, I think. We do have to... Actually, I don't think we really have to do much. I think it's just, if we do the check, instead of at the very bottom line, if we just do make our check for should we scroll, one line higher, I think that's it. I think that's the whole solution. And where do we do that? Where do we do that indeed? So, back to check and scroll. We check to see if it's 23C0. That's easy. So 20 less than that is BA, 23A0. If it's that easy. I think it might just be that easy. And now we wait, and now we watch, and now we enjoy. You can do it. I believe in you. Okay, kind of, sort of. Oh, that's gonna be interesting and annoying. Yes, so you know what's going on is that we are beginning scrolling when we hit the second to last line, the penultimate line, but we're not. That's not where the memory that we're writing to needs to wrap. They are subtly different. They are one line apart, and that is why things are getting screwy. And you can see it accumulating errors every time we do a wrap. It's going to move down one more time. Watch, when we hit this line again, it's going to basically jump another line forward. Yep, see, and now we're printing 2 lines ahead. And that's going to keep happening because we assume that we need to scroll and we need to wrap where we're writing in memory at the same time. And that is not true. We need to wrap when the address we're writing to hits 2C0, but we need to scroll when it hits 2A0. So that's a little annoying just because there might be a decent hack for this. Assembly is always good for decent hacks, but yeah, this whole check was to check both of them. It was a one-stop shop for do we need to scroll and do we need to wrap the Y address, but we need to scroll at 23A0. So yeah, I actually think if we first check to see that the low byte of the video address is if it's C0, then we can jump to wrap Y address. Let me see. We probably need to set up another label for this, because basically it's if it's A0, we can jump ahead and do the scrolling part. Yeah, see, this is going to be annoying because we set the is scrolling flag as soon as we need to wrap the Y address, which ain't no good. So let's just, I already know I'm going to need to do two compares here. So we'll need to do a compare for C0 and a compare for A0. And let's see. Let me review this code. That will be some other label. So if it is C0, then we need to wrap the Y address, which does not necessarily set the screen a-scrollin'. In fact, that happens after the screen starts scrolling. So, can I... Our first streaming disconnection in a while. I'm pretty happy with that, honestly. So, can I... Right, because if we're not at 23 anything, then we just jump straight to check scroll flag. The important thing is, if it is at C0, then we'll just jump to the part where... Thinking this through. Let's check let's check C0 first. We will use the wrap Y address label, and this will not be wrap Y address. But if it was C0, then we'll do wrap Y address and I guess exit? I think we just exit. I don't think we need to do anything else. I don't know. We'll find out when it's wrong. So that is just to wrap Y, which, mind you, a wrap on Y may happen. It'll happen anywhere on the screen, depending on how the scroll is set. Where that division between the two the two mirrors of the screen could be anywhere on screen, depending on how we're scrolled. So wrapping Y address means nothing about having to scroll. Though wrapping the Y address and scrolling may happen at the same time. That's the tricky thing. That's the tricky thing. So if it is, the only reason we check 23CO is for the first time we hit the bottom of the screen. After that, we don't care. We don't ever care about 23C0. Or rather, in this case, sorry, it's going to be 23A0. That's the thing that triggers, oh, we start scrolling now. So, blah-de-blah. So right now, we check to see if the high byte of the video address is 23. If it is, then we also need to check to see if the low part is C0 or A0. If it's not, then we can just go ahead and check the scroll flag to see if we need to scroll. But if we just go ahead and do that, we might miss the Y address wrapping. Right? So we kind of need to do both. Yeah. So actually, let's move. Let's not jump check scroll flag. Let's make a new label. Let's call it check for Y. Check for scroll wrap. And that will be just above here. Check for scroll wrap. And so we check to see if it's 23. If it is not 23, no, that makes no sense because it would have to be 23. It would have to be 23 for us to wrap in memory. So never mind. I don't know what I was thinking there. So if it is 23, we check to see if it's C0. And if it's C0, then we do need to wrap the Y address. Actually, I think... This is very straightforward and it's eluding me. Because basically we want to check for wrap Y address regardless of whether... well, we want to check for wrap Y address every time that is 23. But you don't necessarily need to check if it's 23C0 every time. But this bit is skipping it every time. I think my brain is just overcomplicating the hell out of this right now. If it's C0, we do wrap Y address. If it is A0, then... yeah, we definitely don't RTS here. Because just because we wrapped Y address doesn't mean that we are not also in need of a scroll. Or really the other way around. I think this. So if it was A0, actually if it was not A0, then we need to, can we just bail? So if it wasn't 23, last thing we need to do is check the scroll flag, right? Yeah. So if the high byte was 23, if it was not 23, we jump to checking the scroll flag. And necessarily, we also don't care about checking to see if the memory needs to wrap because that would also require this to be 23. That's what's escaping me. So we can just jump all this. We don't care about checking wrap Y address. We just check the scroll flag. If it is not set, then we are not scrolling right now, and we can get the hell out of here. Otherwise, we jump to do screen scroll, which I also feel like I could make this more readable by doing these backwards. Well, no, I need to jump over wrap Y address anyway. Which is all a bit hairy because I could probably put wrap Y address in here and skip over it here. Actually, let's just do that. So if it is C0, let's do if it is not C0, then we will jump to a new label called check scroll needed, which is, or maybe check at bottom. Yeah, sure. Then this will be check at bottom. Remember your colon. Always mind your colon, and then we can just move this whole wrap Y address code up between those two areas, and that will be much more sane, much less spaghetti. Yeah. So check to see if it's 23. If not, we check the scroll and do the scroll if we need to scroll, and then we get the hell out of there. And actually, yeah, that obviates the need for this. Check that out, because we don't need to jump over that code anymore. And yes, so 23, if it is C0, we if it is not C0, then we check to see if maybe it's A0. But if it is C0, then we increment this guy, and I guess we could jump over this too. Do we need to do check scroll flag? I think yes. So, clear carry, branch, carry clear, to check scroll flag. Okay, and let me comment that, because I was just complaining about not having things commented earlier. So, if we are at the end of the name table, wrap to the beginning. Cool, that probably just broke everything, but then we'll just unbreak it again, baby. And the whole reason for doing this, I already forgot. Oh, because the wrapping was off by one when we hit the edge of the screen. Cool. Which I said was probably as easy as just checking for A0 instead of C0, and I was wrong. There you go. Gave us a chance to clean some things up, you know? Be a good custodian of our own codes. Let me get this away from my fat face. Fingers crossed. I hope everybody has bated breath right now. Hey! Now that looks correct. I will also want to check to see if the line feed way through this code also still works. But that is working perfectly. That is working exactly perfectly. And if I check the other one and that still works, then folks, that means we're done with text output, at least for now. Pending any zhuzhing that we need to do for what BASIC is requiring. Which again, might skip BASIC, because I only have several weeks until almost a month exactly. Like a month from this last weekend until Vintage Computer Festival Midwest. So that's a thing. And, you know, I like to believe in myself, but I highly doubt I will be able to get BASIC ported by that time. So maybe let's take the tack of let's get the keyboard working, which I don't think will be too bad, and get this connected up to serial and just do some simple serial back and forth with some kind of other machine. And that's what I can show off at VCF. I think that's a lot more reasonable. And then we can continue. We can proceed to getting BASIC working. And I would really like to get the floppy drive working on there, because I bought these floppy controllers ages ago and I have not used them. And they should be perfect to interface with a 8-bit bus. So, but yeah. So let's check the. I'm thinking what I'm going to do here really quick is back in our. Whoa. No. Yes. Oh god. I hope I didn't screw anything up too bad. I wasn't looking very closely. let's go back to our echo loop, and I think what I'll do is we will do part of this wrapping and part of this with line breaks. So here I will transfer X into A, compare with I don't know, 80. Let's go with 80. And branch if, now I have to think about this because I want to do greater than and less than, and it would be, I want to skip, I mean, it doesn't really matter. I want to do one or the other. If it's wrong, I don't really care. But compare sets all the flags, blah, blah, and it does the subtraction, blah, blah, subtracts one from the other, sets the flags. So if you subtract 80 from something that is less than 80, you get a negative number, so the 0 flag would be set. So if we are, I think I want to do wrapping first. So what is the thing for, what is it, branch positive is like branch, is it BPL? I have BPL in here. I really don't trust it. I've gotten it wrong like every single time I've looked at it. BPL, is that a thing? Oh, that is a thing. Branch on result plus. So only if X is currently greater than hex 80 do I want to jump over the printing of the align break. So let's make a label called, I don't know, skip break. And that should do that. That should print 80 lines with the wrapping and then print the rest with new lines. Is the theory. And I should also probably really go back to filling this up with black, but the white borders are kind of dope. I think I'm just going to keep it for the moment. Okay. That didn't quite work the way that I was thinking. It certainly is interesting, though. And I mean, it works. I think that proves that it works just fine. Okay. What? Let's see if chat said something funny about me screwing up. Gerald says, would it be too much effort to have a top and bottom margin too, like the C64? No, I'd just have to zhuzh some things, but honestly, I'd be losing so many characters at that point. I don't really want to. I realize that's just an aesthetic call, so bummer to you. I choose not to. And also, like, I want to be done with this portion, so it's working. At some point, I will get this code onto GitHub, and then if you would like to put top and bottom borders on, it should be pretty easy. Wereworm says, I think it's fundamentally different from the C64. I think he's just asking aesthetically. Yeah. He says that right after. I meant look like, not function like, having a border all the way around, and yes, it would be. Dirt Piper says the test ought to say techno, just because. Is there like a meme or something that I'm missing there? Anyway, totally worked. Not the way that I wanted it to. I don't even understand how this is possible. X should always have FF in it. Oh, no, because I screwed up. Right. It's getting bunged up by the print. Duh. But print string and subsequently print character use X, and that's why I'm pushing it. Herderp. But I think I just have to... I'll push it and pull it again. Whatever. Pull A, transfer A into X, then do the thing, and then push it again. Yeah, so like right before here. Yeah, because I can't, because print character will screw it up. So I don't think transfer and... Ooh, will these screw up the flags? I don't wish to screw up my flags. Hold up. And I don't want to double pull my my stack value. So let's see. We push it. We always push it. We push it real good. Then we pull it to do this comparison. And then we... I guess I could just check if because pushing almost certainly won't send any flags, but will transferring X into A. I assume that would pretty much set like 0 flag and stuff. But I don't care about 0 flag. I only care about the negative flag. So I don't know. Let's see. Transfer X into A into X, transfer A into X. Hello? Hello? Transfer A into X. Transfer A into X, please. Good enough. It messes with the negative flag. You absolute bastard. You couldn't just make this easy on me, could you? Because if I could do it before, if I could get it pushed before we do the branching either way, then that would be excellent. But if I do that, then it will screw up the branching. So, ugh, gross. I guess we'll just push, or transfer X into A and push here, and then we'll just need to, let's see. So if we take this, so we've just pulled what we had on the stack off the stack. If we do take this, then basically right before skip break, or right at skip break. Oh, this is so gross. Do I have to? Yeah, TXA and push just to keep my stack balanced, and then also have a freaking label here called didn't skip. This is not a good way to do it, but I'm not going to think through this too much. As usual, that's my motto, and also, like, this is not, we're going to throw this code away, like, as soon as I'm done with it, so if it works, screw it. No skip, whatever. And that will just skip over this stuff, and clear carry, branch carry clear, no skip. This is overkill. I already showed that it worked. This seems like such a shit way of keeping my stack balanced. But what you gonna do? What you gonna do? And you know what? Just because I know this is probably gonna be unpopular because those borders are cool. I think everyone agrees with me. But I'm gonna change it back to black. Because that's the way it's supposed to be. All right, run it. There's probably someone behind my dumb head again. Bated breath. I mean, so far so good. It's just the question of at some point, is it going to switch to new lines? Might take a minute. Because hex 80 is not a small number. Hey! Alright. some of the grossest code I've written, but yay! Look at that. And like I said, I think that's that for text output. We've got a print character function that does everything, handles character positioning, handles new lines and software scrolling, and I am very happy with that. That is like section 1 wrapped, done and dusted. Except for, of course, the important outro where I'm going to drag a camera over there and get this on a cart. Actually, first I'll get it on a cart, then I'll drag it over there, then we'll run it on the real hardware. But not without me checking chat. The Techno DS virus. This is following up Dirt Piper's, it should have said Techno. DOS virus. I am not familiar. I don't know my good old DOS viruses. That's slightly before my time. So, apologies, but you'll have to recant that story to me at some point. Keyboard, confound it, says Dirt Piper. Yes, yes. Trade MC says, no light blue on blue text. Honestly, I think it looks kind of cool, but it's pretty unreasonable. I didn't grow up with a C64. A C64 is one of the few, like, classic 8-bitters that I don't have. Friend of mine, actually, his parents, their parents had a C64 sitting in the basement that I saw boxed up and asked about it, and they were like, oh yeah, I don't think they're using that for anything. And then I never heard about it, and they probably sold it. I don't know. But it was my one chance to have like a potentially free C64, and slipped right out from under my nose. Okay, let us burn a thingy. And it has been so long since we have done that my computer's restarted several times, and I don't even have the programming software up anymore. XG Pro. Derek Koningsberg says, I grew up in the Laser 128 and recently picked up an Apple IIe to tick the box. I like the Apples. They're such dumb, terrible computers. Like, compared to, they came out and they were great. Like, the Woz's engineering is on display. It's really neat, the amount of stuff that he managed to get it to do with such modest, hardware when you look in the actual thing. But also that means that, it's impressive that it can do what it does given the hardware it has. But then, like, the second that, Commodore made their own video chips and other companies started doing that, like, it didn't matter anymore. And it was totally affordable. And now the Apple II sucks. So it's always in a funny place for me, because it's kind of like, it's pretty garbage when you compare it to, like, stuff that's roughly of the era. But it's still cool for what it is. It's a silly machine. Let's program a chip. I have to go get the thingy. I have to go get the repro cart. And we haven't tested this since I dropped it on the floor and destroyed it, so, fingers crossed on that, too. Because I resoldered it back together, but did I do a good job? We're not going to know for a couple more seconds. And then I'm, as mentioned, going to have to wiggle the NES power cable just so. Because it's just screwy. That's what it turns out is the issue. I did this the wrong... No, I did this the right... No. I did this the wrong way around. Up, chip in, then down. There we go. Okie doke. Let us do the old cycle that we haven't seen in a while, but we all know it. We all know how it goes. Load basic.bin. Set the offset to 10,000 hex. Hit OK. Hit not check ID. Hit program. Hit program. Programming. Verifying. Succeeded. So I haven't broken that cheap. I haven't broken that cheap, at least. Into the repro cart it goes. That was not, I don't know if you could hear that, but that was a concerning sound. But I am going to choose to ignore it for the moment. Okay. Let's try using this guy again. How about, let's just go over there while I'm doing this. Okay, let's see if this looks good. It looks reasonable. How should I orient this? Maybe a little bit down. Sorry. Maybe a little bit back up. Sure. That's about as close as I'm going to be able to get you. So just, you know, whatever. Yeah, I think I'm waiting on something and there's nothing to wait on. Let's just do it. This monitor on. There is nothing to it but to do it. And actually plug the power into something. And also look at my pajama pants, because you can't judge me, damn it. And we'll just hold this because there's no other way to get this to work. Okay, monitor is on. Let us get the repro cart over here. And plug it in. And get the tweezers of destiny. Oh! It's fine. It's fine. I probably broke the chip again. Have I ever mentioned that I'm a clumsy person? Don't worry, it's perfectly fine. The amount of times that I do this in a day. Here, let's just pull the Atari forward just a touch so I can push this back just a touch to make it just that much harder to yank off the table. Now that's entertainment. Oh, nice. And none of my connections actually came loose on this thing. Hold on. It just came out of the socket. That is the best I could hope for. So I just got to fix some of these legs. What you gonna do? Ooh, that one got bent interestingly. Are you all excited yet? Are you excited? This should be exciting. I don't know if this should be exciting. I mean, I have more of these sockets. One of these got jammed up. Actually, let me take the chip out because one of the legs got jammed up next to the pin, and I need to pull it back down. Is this a fun angle for everybody? Because this was not what it was intended for. I'm just going to work in silence for a second. Advance apologies. Oh, and now I have just popped one of the sockets completely out. But if you weren't prepared for a moment like this to happen, then you have not been watching my channel. This is canonically accurate. This wouldn't be half so bad if it weren't for the very light gauge wires that are going between this socket and the other socket, because I feel like I'm going to break it at any second. You know what? but this is just too fiddly. I am going to just grab another socket really quick because these wires are going to be real easy to resolder. Heat up the old soldering iron. I'll just unsolder that socket. We will get back to it. Because I bought a ton of sockets recently. Oh boy. Still super duper sore from building deck stairs. But we got them on. Very happy about that. They're looking good. I still got to put on a handrail, but that is much less daunting than, you know, calculating and cutting stringers and whatnot. Okay, I just got to remember. Short one goes from whatever pin is bent up on that side, which I can review later. Here, let's get this closer. Okay, long one goes to the bent pin on that side. Short one goes from the last pin to the bent pin on this side. Okay, so. Oh, that is not the right kind of socket. Oh, yeah. And they're the cheapo sockets. What you gonna do? At least I don't think you could plug the machine pin sockets into each other, so this is probably the best we could use for this particular application. For this particular absolutely nonsense application. All right, so this one is the second to last pin on here. That is bent up, and that is the one that goes to the wire that is this guy. And then this one is 1, 2, 3, 4, 5, 6, 7, 8th pin. Can you tell I am clumsy yet? 1, 2, 3, 4, 5, 6, 7, 8th pin. Pop some solder on the pin opposite pin 1, which I guess would be pin 32 because this is a 32 pin socket. Not enough to prevent it from going in the socket, importantly. Get some solder on this guy as well. Connect this guy here. Connect it to pin 32. Way too much solder in there, but try not to worry about it too much. And that's that one. And then we just need to do the one that connects to the board. Super glad I bought sockets. If I had not bought this random box of sockets, I would be out on my ass right now. Okay, that seems fine. And then it goes in the other socket. Hold up. What is going on here? Have I done it the wrong way around? Yes, I totally have. Really? Yes, very much so. Redo. I mean, I guess, really, I could just turn the whole socket around, but that would be confusing. And I have already confused myself plenty. All right, I have a bajillion sockets. Let's just do one more. And all I need to do is make sure I do it not the way I did that one just now. This is just, it's just building up the tension, you know? This is very purposeful. All right. 1, 2, 3, 4, 5, 6, 7, 8. And second to last on this side. And some solder on everything. There, lid on there, lid on. Let's just make sure. Oh boy, which one is right? A little on this pin. Hold up. I bent the wrong one here. Oh my goodness. You can do this, man. You built this in the first place. You know how it goes. But you also have the scatteriest brain in the known galaxy. Put a little solder on that pin, which I promise that is totally the right pin this time. And then it is this pin that needs a little solder for the jumper that goes over to it. Let's use some fresh solder, not the old gunky stuff on my iron. Should more than do. Finally, reconnect these the right way. That. This wire routed so it doesn't get in between anything. Get it over this corner. Come on, there we go. There we go. Happy clouds. Solder on the one that actually goes to the board. Your arm's too tired and you need helping hands. That seems on there. No, it doesn't. It's lying to you. That seems more on there, maybe. And then you figure out which frickin' way this goes. And how the heck you had this routed in the first place. Oh my. But did actually get the connections right, so that's positive. Oh my lord. Did this go across the front? Well, whether it did or didn't, it will work that way. Okay, I think that is a successful rebuild. I think. Nothing to it but to do it. Great, I've shoved out another one of these pins. That's why these things are regarded as cheap pieces of shit. Okay, that seems in. Okay. And I was avoiding reading chat, but now that I have fixed this, Gerald says, "Nice, stayed intact." Oh yeah, snap into a nest, Jim, says Trey. Wereworm says, "Gravity checked, successful. You forgot to step on it after it dropped. Sorry. I didn't get anything stuck in my foot this time either." Man, you guys, it looks like you had some other good conversation about that too that I will have to dig into in a minute, but I really mainly want to get this working. So, sorry, nausea. You had to have known this was coming by now. Oh, good enough. That is fine. Why not? Get back in there. Let's make sure we actually get some video. Yeah, how do I have to arrange you? Has it finally become impossible? It's going to be very disappointing if this is just all the way broke now. Do I have to do the insane work of popping open the power brick? Because that would be interesting. I don't know if it showed up on the video, but the power light did flash on, so this thing was... Nope! No matter how much I play with it, that's not going to work, because it's not plugged into the power strip on this end. Trickcha. There we go. Okay. It's not so far gone. I will still need to probably crack this brick open at some point and fix it up, but hopefully assuming it's not totally potted. But we have life. She lives. And I'm going to gently set this on the floor so as to not yank that off of the thing again. And find the tweezers, and successfully retrieve the tweezers, and turn the soldering iron off before I set the basement on fire. And I have turned the soldering iron on, and then I am just walking away. Okay, get that gently adjusted. Gently, I say. And I know half the screen is covered up. I'm sorry. Whatever. I'm not that fussed. Okay, I'm just gonna go for it. And it's not doing anything, which is possibly because my mod is wrong. My bodged in chippy thing. Or just because we're not making good contact, or some weird thing. Let me continue fiddling. Checking for any bent pins. Pretty good. Everything still looks connected. This looks reasonable. I think what I need to do is shove it in harder. That is always the answer. Oh, wait, hold up. Hold up. I see a pin that might be unhealthy. Yeah, there's a jammed up pin up in here. Oh, Lord. Are we having fun yet? Because I've gotten to the end of the thing, so this is not one of those things where I can just say, just take my word for it. We'll see it next time. This is the end of this section. Even the crickets are impatient. Yep, there is a leg stuck on my... Sorry, I would take this over there to be more interesting, but this is too fiddly. Okay. Pin back in. Looking a little healthier. It'll have to do. Or it won't do it all, I guess. Those are my options. Oh! God damn it. God damn it. Figured out why that pin was screwy. It was because it was getting jammed into a location that it was not supposed to go into. I am apparently off with one of these things. Shit. More adjustments. Coming back that way. Because if it worked the first 2 times, that would be no fun at all. Alright, so this leg is off. It needs to be 1 over. Probably because I counted from the wrong direction, if I were to imagine. So, heat that iron back up. Wareworm says, I spy with my little eye an Atari. Yes, and I have not done much, and especially definitely have not done enough with it. Wareworm says, you could fix the breakage, or fix it with cable ties in a position where it conducts. All options. All options. Okay, so not this one. This one. I'm going to bend it up and I'm going to check that it actually lines up with the jumpered pin below before I do anything else. And I'm glad I did that. Oh, duh! It would be the twisted up pin. That makes sense. Yeah, I went the wrong direction. Which is good, because that is the most mangled pin, and having it not have to go into a socket is going to be better for it. That explains why this wire felt a little short. Come on, baby. You gotta... I have to do this correctly at some point, right? Just by, like, sheer chaos. Okay. Here we go. Get at it. Everything actually looks like it's in the right spot. Come on, come on. Just work this time. Here we go. Prepare yourself. Alright, I'm only giving this so many more tries. If this didn't actually work, then we'll just have to do it again some other time. I have things to do. I have a life to lead. I made a cracking noise while pushing this in, which again is certainly a good sign. I can't imagine any world in which that's not a good sign. Okay, get it in the slot. Find my tweezies. Precariously. Adjust the power thing so it actually turns on. Hey! Oh, come on. Come on. I don't know how well you guys can see that. Here, let me... sorry, this is going to trigger everybody, but I don't have a better method of doing it. Alexa, turn off the basement.
Okay.
There we go. Okay. Well, it still sucks. That really didn't help out at all. You'll just have to believe me that that is text. Hey! I can't read from this far away. My eyes are terrible, but I think it's SKM Geek. There might be an I in there. It might be Skim Geek. I'm just gonna... You know who I'm talking about. Can't believe I got to join in live. You just got here at just the right time. Because I just got this working just now. And you can't really see what it's doing, so maybe I'll try and drag the camera a little closer. Looks really good from here. One thing is, and maybe you'll be able to see this when I get the camera closer, but the very bottom line is actually visible on the screen, where we assumed it would be. There's the new line ones that are new lining. That was off the bottom of the emulator screen is in fact visible here. So in a perfect world, I would clear that line out as well, but in this world, I don't give a shit. So that's going to be what it is. All right, let me set this down. Oh, come on. Come on. Just want to get this adjusted into some kind of formation where it will work without me having to hold on to it. That seems likely. I don't think this camera will get closer. Sorry. I mean, it'll get closer, but I don't think it's going to make much of a difference. And then I'm going to have to hold it anyway, so you guys will have a bad time. So let me see about the other camera. Yes. Will this just work? Not really. Okay, they are all equally terrible. And I don't think I can also get this one a bit closer. Sorry. I'm sorry. I'm sorry. I mean, you believe me, right? It looks great. It looks great over here. Looks fantastic. Let me see, I can actually adjust the aperture on this camera. It probably won't make a lick of difference. In fact, I think that made it worse. But, sorry, trust me, it's alive. It's alive. You just gotta trust me. You've just got to trust me. Alexa, turn on the basement.
Okay.
Hello? Alexa, turn on the basement.
Okay.
There we go. Okay, so, where do I sit? Over here? Let's see, so that we can still get the screen in the background. And I'll go over here. I don't know where I am. And I'll, like, point my mic at myself. Here we go. Because this deserves a little bit of an outro. I don't know that I have anything to say. But, you know, why not? We did it. This is a milestone. So, yeah. I would just like to say thank you to everyone who has been here up to this point and gotten me through, like 2 weeks of working on this thing to get to this point where it's doing texts, which I'm very excited about because I was never really that excited about this portion of it, except for the possibility of doing silly characters because I knew I wouldn't have, you know, all of the characters that I needed in the character ROM. That was just not going to be a thing. So that seemed fun. And, you know, I'm a programmer. I like programming, so that'll always be fun. But getting to the keyboard part where I get to build some hardware and actually interact with it is what I'm really looking forward to. And now I can finally start on that. So I am pretty jazzed. So I've been really happy with, like, the interest that people have had in this. I mean, of course, I'm a super small-time channel, and, you know, the fact that these live streams get, like, about 100 views is still pretty impressive to me. Like, who wants to watch some guy futz around for, you know, a couple of hours every weekday? But it's just fun for me. So if it can be fun for other people, too, and you want to watch me doing my hobby, I absolutely love having you here. So thank you for spending time. I don't know if there's anything else that I want to say as far as this milestone. I mean, it's done. We can print text now. It's a PC. That's the name of the thing. Let me scan some chat before I go. Yeah, it's alive. I saw that earlier, and yeah. I had no doubt. The amount I've screwed up here with the hardware, it's very forgiving. I didn't expect it not to be. My hospital room, this is Dirt Piper. My hospital room had an Alexa. I used it exclusively to look up Three Stooges trivia. I don't know the last time that I watched Three Stooges, and it was probably because it was on, you know, like TCM in the middle of the day or something. Not to besmirch the Three Stooges. I haven't watched Three Stooges in a long time. Alexa, acquire world domination, says Wereworm. There. Now it's
Sorry,
been said.
I didn't
So,
find a group or device named Aquarium
if it was
Light.
going to trigger something, now it has. And the last one that I have from Trey Dempsey, which I think is fair because Trey Dempsey, Wereworm, and Dirt Piper have been my ride or dies so far. So, right on. The last one I'm going to read is, are you going to build an interface similar to the Famicom keyboard or your own interface? Yeah, because I guess you weren't here when I was kind of first talking about that. I blathered a little bit earlier on, and this is a good one because it leads right into like what I'm planning on doing next time. So the one for Famicom Basic uses the port that's on the front of the Famicom, which is it uses the same registers as the controllers on the NES, but it exposes a couple of signals that the NES does not expose. And mainly you get one extra input pin or output pin, I can't remember, but it's just enough that basically the way it works, and it was kind of cool because I came up with this independently too, and then I found out it's exactly the way their keyboard works, and I was like, oh, nice. Is, you know, it's scanned in a matrix, and basically one side of the matrix is 8 bytes or 8 bits wide. Not that it really matters. You can clock in however many bits you want, but basically what happens is you, just like you were pulling a controller, you hit the reset line, or not the reset line, the latch line for the controller would latch the inputs into the shift register. On the keyboard, it latches, it sets one of the Y matrix lines and latches the X outputs, and then you clock, what you're clocking in is the X inputs that were set by the Y line, and then when you do the next latch, it moves to the next Y line, and you clock in the next ones. But the thing is, you don't know the state of the keyboard at startup, right? You don't know what matrix line it was at, because it'll start up in some random state. So the way that they deal with that on the Famicom basic keyboard is they use that extra line that I don't have to reset the keyboard. It's a reset line to it. And I don't have an output on here for doing that. I only have the one output, and that's the output used for latching shift registers. So the hack that I have come up with, and that I'm going to try and implement, is just put a extra like ninth or what, I don't know what, my keyboard has a fixed matrix on it, the one that I'm going to use. So however wide the one side of, like the output side of the matrix is, I'm going to add one extra byte to the, or why can I not get this straight? One extra bit to it, and that one is going to be hardwired, and like the first matrix line is going to have that tied either high or low, whatever, it'll be different from all the other ones, so that I can clock in the states of everything. But when I first start up and I am initializing the keyboard, what I'll do is I will latch it, read in all of the bits for that row, for that column, I guess, and then check the ninth bit and see if it is, kind of that check value. I can't think of the word for it right now. And if it's not, then keep cycling until we get back to the top, and then we know we're at the first line, and we can. So that's my workaround. But otherwise, accidentally, that's like I said, I kind of had that plan before I did any research on the Famicom basic keyboard, and that's apparently exactly the way that it works, except that they have a reset line to reset the state of the column counter. So, good question. So that's what we'll be working on next time. Is I have this guy. I have shown it off early before, but and sorry, I know I'm out of focus. This camera is fixed focus. I mean, it's not. I can adjust it, but it's manual focus. This keyboard is a TI-99-4A keyboard from a TI-99-4A that I bought years ago and then ripped apart like a jackass, and the keyboard is like the only part I still have of it. But it's a nice just matrix keyboard with what am I looking for? Actual mechanical switches on it, so that's nice. As you can see, all of these wires coming off of it are because I just hardwired up certain keys for to just act as switches for certain things, to play around with arcade cabinets and stuff, because I didn't have joysticks and whatnot. So as part of that, you can maybe kind of see, like, this board is pretty chewed up because I cut a bunch of the lines. So I'm going to have to start by fixing those lines. One nice thing is that I found somebody already pinned out the matrix for this keyboard on Instructables, because Instructables has all kinds of weird shit. So once I get that repaired, I'm not going to have to reverse engineer the matrix. It's already figured out, and that would take like a whole episode, so that's going to be nice. But yeah, and then I'm going to build a circuit with, a counter for the Y line and a shift register for the sampling of the X line, and that should basically be it. It should be pretty straightforward. It'll still probably take a couple episodes. But I think that building the keyboard will be the most of the work. I think, building the keyboard read software will be relatively straightforward. And then it'll be fun because we can wire that up to our character printing stuff and, have our own TV typewriter. But yeah, let me scan chat again really quick. And I have to go because I have to get a haircut for the wedding that I'm going to, which re-update, I already said on the YouTube social stuff that I am going to be on vacation from Thursday, this coming Thursday. I will be out for the entire subsequent week because I didn't mention that part. So I will be back on the Monday the 19th. is when I will be back streaming again. And then we will start on the keyboard. Yay! Okay, back to checking chat. Derek Koenigsberg says, it would be great if you could plug in through the expansion port on the bottom, but no idea how you'd get the connector for that. Yeah, I was hoping to, like, if I get when I get around to hooking up the floppy and whatnot, and I guess now I definitely have to hook up a UART for what I'm clearly planning to do at VCF. I was hoping to use the expansion port, but yeah, it's a weird connector. We checked it at the beginning of this whole thing, and it's like, it's too wide for a card edge to slide in there. Like, you'd need a 2-card thickness thing. So you'd need like a custom connector to get out of there, which is quite a bummer. So when I get around to adding extra hardware for the funds, I will definitely be tapping off of the cartridge. But what you gonna do? Yeah. Alrighty, that was that. Thank you for coming along on this ride. I like that we have a nice natural break here. Like, I'll be working on the keyboard a bit, tomorrow. Like I said, Wednesday, I'll probably try and do a pretty big stream because I have the day off, but I will still be here. But yeah, very excited. This is getting places. And I wouldn't have put in a couple hours every single frickin' day like a moron if it hadn't been for you, kind folks. So I hope you enjoyed it as much as I enjoyed doing it, and I will see ya. Love ya. Bye.